Hi everyone, and welcome to this YouTube channel. My name is Penny, and this is Penny's Coding Bits. This channel is dedicated to bring you weekly bite-sized videos with practical solutions for your everyday data analytical challenges. And this video is going to show you how to create a solar eclipse tracker in Rstudio to track the total solar eclipse that is going to happen on April 8th across Mexico, the US, and Canada. So the idea is that you can slide along the time slider so that this marker moves along the path of the solar eclipse. And as you slide, the local time changes. And this is the local time at the particular place that the marker is at, so that you can plan when to get to this place to watch the total solar eclipse. And you have the latitude and the longitude for this coordinate, and you can plan your travel accordingly that way. So once you are satisfied with a spot, you can zoom in to see what the nearest towns and cities are. And you could plan where you should stay for your visit. And the idea for this tracker was that I couldn't find anywhere on the internet that shows me for the entire span of this solar eclipse what to plan for to get to a particular place and when to get to this place to watch the total solar eclipse. So I made this tracker from the NASA's website, and we'll get into that later when we go through the backend code. So now that you have the local time for all of the spots along this solar eclipse path in 2-minute increments, so you slide up and down, it will +2 or -2. So this should serve hopefully most of the people that is near this solar eclipse path, and hopefully this can help you plan your visit. So let's have a brief walk through the backend code that supports this tracker right here. First of all, we need all of the timestamps and the coordinates along the path. And this data frame, which is a table in data science terms, is the backbone of this tracker. So all of this data is coming from NASA's Eclipse website. And for this particular solar eclipse, it has all of this data. And for this tracker, we are only using the central line. And we need to do two things to convert the information in this table to this data frame. First of all, we need to convert the universal time to the local time. So we need to look up the time zones, and for all of the time zones, we need to minus 1 hour because we are on daylight savings time in North America right now. So if normally we need to subtract 7 from a particular time, we need to subtract 6. So for example, 1642 should be 1042 in our dashboard. And the second task is to convert the longitude and latitude in this format to decimals. And the way you do that is to divide the minutes portion of the longitude and latitude figures by 60, because this is the minutes portion of the longitude and latitude. And the reason why this is in minutes, which is a time denomination rather than a distance denomination, is because in the old days, the sailors who traveled across oceans used to use time figures to tell distance. So, for example, we have 24 hours in a day. So, 1 hour, which is 1 over 24, is equal to 15 longitudes. When you measure the distance between two different places, the most convenient way is to measure how long will it take you to get from point A to point B. Thus, we are using minutes in longitude and latitude figures. So, once you divide this by 60, you simply add on the result that you get to this degree figure in the longitude and latitude columns. So let's take an example. So 1042, we have 550.2 S for latitude. So what we do is divide 50.2 by 60, which is 0.837. And we add on the 5 that we have here to the 0.837. We get 5.837. And because we have S, which stands for south here, we add a minus sign to the decimal that we have. So that is how you convert longitude and latitude figures from this format to decimals. So once we have that in place, we have the code that makes up the design for the dashboard. So here we have the title that is called Dynamic Path of the Solar Eclipse. And we have this code chunk here to remove all of the labels along the slider bar. Otherwise, we will have 1, 2, 3, 4, 5, 6, 7, 8, and that doesn't mean anything in time denominations. So the good way to deal with this is just to get rid of them all and just have a clean slider. And we have a defined variable for the slider called slider input. And we have the text outputs for the time and the latitude and longitude. And last but not least, we have the map that is being shown using the leaflet package in R. And for those of you who are interested to learn more about leaflet, click on the link in the pop-up on your screen right now. And that will take you to the New Year's travel dashboard that I had built in December, and that goes into detail on leaflet. And once we are having the design for this dashboard in place, we could set up the back-end logic. So first of all, we need to have some sort of reaction when the slider bar moves. So that is where this reactive function comes in. So it picks up a particular row in the Eclipse data frame when the slider bar is being moved. And with this selected data, we will be able to separate out the local time from the selected data and the latitude and the longitude, because the time and the coordinates are being used separately down the road. So once we have these outputted and assigned a variable, we could begin to show our map. And you can see that we are using the render leaflet function right here to help us with that. And to show the map, we need to have an at tiles line. And so if you look at the map, you can see that there are squares on here. And these are tiles that make up the map. And once we have the map shown, we also need to add the marker that is here. And we also need the polyline to show the path of the solar eclipse. And last but not least, we need the leaflet proxy function to help us to show an updated map each time the slider bar moves so that we don't have to render a new map every time. So essentially, the map is being updated more efficiently with leaflet proxy. So what we do is simply clear the marker and add a new marker. And you can see that this new marker contains the selected data for longitude and the selected data for latitude. And we also need to paste the time in the selected data and the latitude and longitude in text format. So I hope this will be useful to track wherever you want to go on Monday to see the solar eclipse. And I hope that this template can help you to build more dashboards that have to do with maps. I'll see you in the next video.